On the bench here I have a Fluke 510A, which is an AC reference standard. I showed this in a mailbag not too long ago, and now it's time to do a bit of refurbishment on it. It does actually work. I've been playing around with it a little bit. I haven't used it much. I've basically confirmed it works properly. And it outputs 400 Hz, which has got a little trimmer here to adjust the frequency here if it's slightly off frequency, so you can just trim that. And these have different options. You can get these lots of different frequencies like 50 Hz, 60, 400, which is, this one is 1 kHz, 2.4, 5 kHz, 19.2 kHz, and 100 kHz, apparently, according to the manual. Now, because these are basically option boards, you can actually potentially make your own frequency by manipulating those values on the boards, because it actually tells you what the values are for each one. So if you actually had a 400 Hz one like I've got here, and they wanted a 1 kHz one instead, because the service manual does actually tell you all the parts and what the values are, it means you can actually quite easily make your own version and modify it and change the frequency for what you want it to. So that's really nice. Anyway, we'll get into this thing and let's go and do a bit of work on it. It does work, like I said, it's not actually broken. It's just a little bit of maintenance work and a bit of refurbishment because it's an old device. I don't actually know what year this is. I'm hoping there's something inside which actually says what it is, but it's old. So the electronic manual I've got for this thing is dated 1971. I do actually also have a physical manual which I managed to find on eBay and pick that up. So I actually have a physical manual, which is always nice. I do tend to get physical manuals if I can for any bit of equipment which I'm going to keep and I tend to own for a period of time. So this thing is 50 years old. It's older than me. There we go. Look at that, beautiful. Gold. Gold in there. Switch here, I'm not sure what that's for. I'm sure it's in the manual. So there's actually not much in here maintenance wise that I could see from the manual as far as what we need to do to basically refurbish it. All the transistors are in sockets, that's nice. Let's take the bottom cover off as well. I did do this in the mailbag video actually, I opened it all up. These screws have got some rounding on them. The actual heads are a bit rounded but someone's been using the wrong screwdriver on it. But you never know, I mean, this thing's 50 years old. It's been a while. And then you've got a big transformer right here. And this is the board which controls the frequency. Just here. There you go, you can see it says 400 Hz right here. So, I'm not sure if it's soldered in or not, whether it's just plugged in. I think it's actually plugged in, I think it's a plug-in board. Yeah, those are connectors. So, those are little pins sticking off the main board. And you've got sockets on this board. So if you want to change the frequency, this is where the board you change it on. Now this is full of tantalum capacitors. Now these will be wet tantalums. All these types here. These, they don't tend to fail as wet tantalums. They're pretty good. In my experience, they can go, but generally they're pretty good. I tend to not think of those as something which I'd be worried about, unless there's been a main power supply failure or something like that, where you say like ripple coming through this unit or high voltage or something like that. Tantalums don't like being stressed. This type less so. It's the dit tantalums which is the biggest problem. But these cylindrical type are usually pretty reliable. I don't think I've ever had to replace any of those, ever. And this end here, this is what we've got to do. So you've got these electrolytics. That's it, 3 electrolytics. That's all it's got in it, those 3. So those need replacing. Just here you can see this really nice precision resistor. This is Fluke style. A lot of the Fluke gear has got this kind of resistor in it. Obviously they made them themselves or something. But they've got this format. And it's basically a wire wrapped around a former. These precision resistors. So I've seen a lot of gear which is, you know, Fluke branded gear, but you've got those resistors in them. It seems to be their own style of resistor. But yeah, beautiful piece of gear. And not much to do on it. Right, so I was looking at these binding posts here, these white ones. Both the white ones are front and rear, both split. But they're just grounding points, so you actually see this go straight to the chassis. Pretty simple. So changing those isn't going to be hard at all, just because I'm bolting and bolting a new one on. Because it's only slightly split, this one's not too bad. I'm going to put some glue on it. I'll just re-glue that one. The back one's got a couple of splits in it, but I think that's also repairable. Again, I'll just glue it, and that way I'll keep it original as well. All the other ones look fine. There's no splits in the other ones, so that's good. Anyway, we'll get on to doing this. So we've got a 40 volt 250 microfarad there, axials, and this one here I have forgotten what that is, and I can't really see it either. But it's small, so there's a good chance I've got the right capacitor. Quite likely. So I looked at the specs in the service manual for this thing. So these are 250 microfarad, as I said, plus 50%, minus 10%. So I don't mind having a higher value, but it can't be less than that really. And this one here is a 2 microfarad. It's got to stay in a plus 75% or minus 10%. Again, they don't want you to go lower than 2.2 or 2 microfarad rather, but they will let you go to, you know, nearly 4. That's what they reckon as far as the capacitor specs. So I'm actually going to increase them both slightly. So this one here says 330 microfarad, 50 volts. So that's a 50% increase, kind of, pretty much, which is an improvement. And the other one I found here is a 3.3 microfarad, 63 volt. So again, that's an increase of, you know, 50% basically, just to up the regulation slightly. It does mean more inrush current with a higher capacitor value, but it's probably not going to matter on these. I do actually have some 2.2 microfarad caps, so I could actually replace it with a proper 2.2. But if I'm going to change it, I might as well up spec it slightly and go to a slightly bigger one. I mean, I don't know, should I keep closer to the actual original values? Maybe that'd be better. What we got here? That's a 100 volt. So yeah, no problem with values. What's this one here? That's 100 volt as well. So these are 100 volt caps. So I've got options. I could either do a 2.2, which is close to the original, or I could do a 3.3. I might have a look at the diagrams, just have a little think about it. So let's test these capacitors and circuit and see what we get. So this smaller capacitor here isn't actually that critical. It goes to the battery pack option, which I don't even have installed. So it's not even used. And it looks for, look, 2 microfarad perfectly. 10 ohms though. Does a 10 ohm part matter? It's getting up there. But a 2.2 microfarad, I mean, if I got a Actually, I've got one here. I've got one. Put one side. I actually did get one out, planning to replace it. What do we get from this? 2 ohms. So significantly better resistance. Maybe exercising it make it work better. I don't know, but maybe. So let's check the big caps. $300. That's pretty good. 0.6 ohms. That's just measuring right. And although capacitance being increased like that. 1 ohm. Yeah, they're probably alright. What if I get one of these new ones? I'm going to replace them anyway. They are 50 years old. 0.8 ohms, so it's actually comparable to the ones I'd want to put in. They're very similar. They are old. I want to replace them anyway, so it's just done with. Don't have to worry about it. I mean, it's only 3 capacitors to do. So yeah, we'll just change them anyway. Even though they test basically okay. I mean, the small one measured worse, but it's not even being used. 3 electrolytics, let's just swap them out. So to get to those legs, I have to take the transformer out. Thankfully, it's easy. It's almost like it's designed to come out. Now also it's going to be hanging on the wires now, so I'm not sure if I can actually just swing it out of the way. Maybe I can do that. It's not ideal. I hate to rip all those wires out. It is all marked what the wires all are, so if one does break off I can actually reattach it. Now I've got to find out where these capacitors are. I've got to try and find them on this side of the board somewhere. 2 big ones there. Here we go. There, 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 there. That's the big caps. The small cap, I think it's this one here. Those 2 there. So I'll put some fresh solder on, get those off there. I've got my solder sucker ready to go. My desoldering iron. And to balance that on there so it doesn't fall off. So I'll put some fresh solder on. Now I've got to try and get these things out without dropping the transformer. I can't need to get both sides at once. I might just bounce it off the edge of the desk. Yeah, that'll work. So I'm going to pull the capacitors out, I'll clean the holes out with the desoldering gun. It's just easier that way. So I heat up with this. I'm holding the capacitor from the other side. And I should just be able to pull that end out. There we go. And then I'll do the other end. There we go. That's that one. Do the same the other one. And that's that one. Now let's desolder them. carefully roll this over. So let's put this capacitor in. As usual, I've rotated it so you can see the markings. And I'll do the same on this one. Paying attention to the polarity, of course. So that's both of those in there like that. You can kind of see, can't you? And I've got to rotate it back so I can solder it in place. Though I could solder it from the top, to be honest. I could actually do that. Let's just fold these legs around. Let's do it that way. And then that won't move. Let's try and do this so you can see what I'm doing. Balance transformer carefully. And my hand's always going to be in the way, it's probably these sorts of things. I'm using silver solder for this. I'm using my good stuff. I'm trying to sort of get it so you can see what I'm doing at the same time as I'm soldering and see what I'm doing. Sometimes I actually solder from both sides. I'll get it secured and then I'll go back to the top and resolder there, because like in this case there's no track on the bottom side, so I may need to solder the top side to get a nice flow onto that joint across the actual track and the component lead. We'll see how it goes. Sometimes there's a problem. Well, here's another one which is going to be the same situation. Let's try and get so you can see. Ish. I usually put enough dwell time, it will flow through anyway and do the job. So you must have, the solder disappeared, which means it's gone through to the other side. Okay, and the same there. Right. So that's this side done. I'll clip these leads off. Dropped it. Carefully rotate it back. I'm trying to minimise flexing on these wires as much as I can. Trying to. And it could use a bit more flowing on the top side, as I thought. So we'll do that. It is kind of flowed, but not quite as well as I'd like. So I'm going to clean the iron tip. And we'll just do a little bit here. I'll try and get in there. That's that one, and you can't see it. And this one here. See with these older boards, because they've been sitting for so long, you know, it's an old board and there's a little bit of oxidisation of the board and that sort of stuff. Even gold oxidizes, just not the same severity as other metals do, but it still does it a little bit. Get a bit of tarnishing. And so I'll still be refreshing up with that on this side, will be okay. And this one here, that's actually not too bad. I'll just go, this one not need much. Okay, done. Should get a bit of IPR on there, probably on a cotton swab, and just clean up that area. If I drip it on like I normally would do, it tends to creep across the ball, and I don't want to do it on this particular situation. Right, so I get this small capacitor out now, which is potentially tricky. I've already put some fresh solder on the bottom side. I might need some more on the top side here, just so I can get it to wet, so I can then lift this up, just like that. And we'll do the same for the other side. There we go. Separate out. Okay. Somehow I solder bobbed my solder. Solder bobbed onto it. That's annoying. Anyway. Let's clean these holes out. Do it from the top side this time. There it is. As the part's not in the way, I'm going to give it a clean. Okay, so it's cleaned up. If you can see that. Positive side is marked as this end, and it was actually that way around. You can't always rely on the markings on the board. Right, so that's got a positive sign there. There's been equipment which I've worked on which is actually wrong. So never assume that the markings are correct. Always try and remember it. For instance, there's a piece of gear which I've worked on recently. This particular part was installed backwards from the factory because the markings on the board were backwards. Anyway, so that's that. Let's solder it in place from the top, and I'll touch up from the bottom once I've flipped it over, rather than going backwards and forwards. It's not easy to try and do this to video at the same time. Right, let's clean up in a minute. I'll do that after I've flipped it over again and done the bottom side. If the bottom side needs doing, that looks fine. I don't have to do anything here at all. It flowed through nicely. So let's cut those off. Clean up both sides and then we can try that again. So I'm just refitting the transformer, then I'll flip it back over, clean the top side up. Come on, can you go? There we go. In place, double check the wires, nothing's broken off hopefully. Yeah, they all look alright. Cool. So let's clean up the top side. This should work fine. Be better anyway. Right, let's try this thing out and see if it still works. Power onto the unit. Power switch on. Sets AC volts. Let's just shove these in the front. I've only just turned it on, so it's got to warm up and everything. Same for this multimeter here. It's all only just been turned on. So there we go. This will settle down a little bit once it warms up. But it's working. What we can actually do now is check frequency. And it's doing 400.24 Hertz. I don't know if this is wrong or whether this is wrong. I don't actually know which one's wrong, to be honest. Let's do another test. Yes, I should probably put the right leads on this and do this all correctly, but you know, yeah. Volts AC, right. Let's probe into here with this. Compare it with the Fluke. Which one do you believe? The Fluke or the Keysight? Which one do you think is likely to be more accurate? The Fluke or the Keysight? Let's do second frequency. Let's do frequency. See what this thing's about. 400.25 Hertz. So at least the frequencies match. Voltages don't. Which one's right? Usually we'll never know. So I'll just chuck the output on a scope here just to see what the output looks like. It looks absolutely fine. There's no signs of any problems on that waveform. There's no signs of glitching or disturbance. It looks fine. Hardware frequency counter says 400.23 to 26 around there. It's not wonderful, but yeah, that's looking alright. So there you go, it's a bit of a closer view. I've changed the frequency a little bit, just adjusted it a little bit on the front panel of the unit, which is why it's got adjustment on the front, because it's one of those things you need to tweak from time to time, because it's just capacitive tuned, and ambient temperature affects it somewhat. So that's now reading around the right value now, around 400. It's looking pretty good there now. Yeah, it's interesting the way the scope is saying it's 10.1 volts. Well, no, it definitely isn't that. And there's an FFT version of it. I've got it going quite a long way up in frequency here. Actually, let's reduce this a bit. And let's go down to say 1K. And there we are. There's the 400 Hertz here. And basically it's flat each side of that. There's no signs of any problems with noise coming out or anything like that, so it looks good. There we go, that's that fixed. Well, wasn't really fixed, was it? It was a refurbish. It's working fine, happy with that. I've still got to do the gluing on these knobs. I'm not going to bore you with that though. You can imagine me gluing knobs, can't you? So yeah, check out the videos at the end, and if you want to give me a thanks down the bottom there, a little donation, you can do that, or you can become a Patreon and help support the channel and help me to buy things like this to work on and to add to my inventory of test gear to use as references and whatever else I'm going to do. Try and make interesting videos. Alright, thanks for watching. Thanks a lot.